Good morning, everyone. So today we are going to be looking at any questions that you have from the mixtures of strong acids and strong bases. So let me know which questions, excuse me, let me know which questions you'd like to do. And if we have a little extra time afterwards, we can get started on buffers as well. So you can either tell me, unmute yourself and tell me what question you'd like, or you can type it in, whatever you prefer. Oh, no problem. Your brain was buffering. Oh, that's a joke. So how were our mixtures of strong acids and strong bases? Oh, Maya. Everyone, just make sure you have your chat up on the side there. If you haven't found your chat, there should be like a control bar you can click on. Was the whole thing for homework? Sure, although I handed it out really late yesterday, so if you haven't done the whole thing yet, that's not a problem. If you have any questions next time, we can go over them next time as well. Nobody has questions? Well, okay. If that's the case, then shall we just take a look at, just give me a second here. I'm just gonna move a couple things around on my screen so I can get a new page up and we can talk about buffers. Yeah.
May we please go over number 3?
We sure can.
Thank you.
All righty. Let us zoom on down. That's number 2, number 3. There we go. Okay, we want the pH resulting from the mixture of, oh, I gotta get my special writing glove. Hang on one second here. Oh, I've misplaced it. That's okay. Oh, there it is. There we go. All right. So we are mixing 25 milliliters of 0.0420 molar barium hydroxide. So that is our source of OH minus. And we are mixing that with 125 milliliters of 0.120 molar HCl, and that is our source of H+. And so in any of these questions, you want to find your moles of H+, you want to find the moles of OH minus, and then you're going to find the moles of whichever one is in excess. All right, and from the moles in excess, you can then find the concentration. So let's start by finding the moles of H+, and I'm going to make this millimoles because it makes our life easier. So we have 125.0 milliliters times 0.0120 moles of HCl per liter. And there is one H+, so 1 mole of H+ for every 1 mole of HCl. All right, plug that into my calculator here. 125 times 0.012 is 1.50 millimoles of H+. And then we're going to find our moles. Sorry. Then we're going to find our moles of OH minus. 25.0 milliliters times 0.0420 moles per liter, and that is of barium hydroxide, BaOH2. And we are going to then say, okay, we get 2 moles of OH minus for every 1 mole of barium hydroxide. Okay. And that, well, just before we do that, that 2 is the reason we have that 2. All right. And we get 25 times 0.042 times 2 equals, and that is 2.10 moles of OH minus. Okay, now I don't know if you remember from the video or if you feel okay about this, the net ionic equation for any strong acid, strong base neutralization is going to be H plus OH minus gives us H2O. So it is a 1-to-1 ratio for how H plus and OH minus react with each other. So whichever one we have the most of is going to be the excess reactant. So that is going to be our OH minus. That is our excess reactant. And whichever one we have the smaller amount of, that's our H plus, that's going to be our limiting reactant. And our limiting reactant gets all used up. So by the time this reaction is done, we have no extra H plus left over whatsoever. So the moles of H plus is going to be 0. We want to find the moles of OH minus, which are in excess. Well, we start with, that's going to be the moles of OH minus at the start minus the moles of OH minus used. And so the moles of OH minus at the start, 2.10 millimoles. That's how much we had at the beginning. And how much reacts? It's going to be exactly the same as the amount of H plus because they react in a 1-to-1. Okay, so that's minus 1.50 millimoles. And we get 2.1 minus 1.5, and that is 0.60 millimoles. Now, because we've done a subtraction in terms of our significant figures, we're going to go to the smallest number of decimal places. And so that's 2 decimal places. So that's going to give us 2 decimal places. So we now have 2 sig figs. Finally, good morning. Calculate the pH. So we're going to calculate, in order to find pH, we need the concentration of OH minus. That's going to be 0.60 millimoles. Now, what's our final volume going to be? That's going to be, let's see, that will be our total volume. So we had a 25 mils and a 125 mils. So we have total 150 milliliters. 150 milliliters, that's our total volume once they are mixed. So 0.6 divided by 150 is, oh, didn't push the button right. 150 equals 0.0 0.0040 molar OH minus. Okie dokie. Now we know the concentration of OH minus. I'm going to do this the way that everybody forgets how to. We're going to take our OH minus concentration and find our concentration of hydrogen. Now remember, Kw is equal to concentration of hydrogen times the concentration of hydroxide. And so hydrogen is equal to Kw over OH minus. Okay. So that is 1.0 times 10 to the negative 14. Whoops. Okay. Over, let's see. What was the concentration? Ah, there we go. 0.0040 molar. And that gives us 1 times 10 to the negative 14 divided by 0.004 equals 2.5 times 10 to the negative 12. And so from there, we can find our pH. pH is the negative log of hydrogen. So that's going to be the negative log of 2.5 times 10 to the minus 12, which is log 11.60. And that has our two significant figures that went with our two significant figures that we got over here. Are we good? Could we go over question 7 for sure? Yep. Is good. Excellent. All right, let's do question 7. 5, 6, 7. Oh, this is a review. This is our saturated solution. So we're looking at a saturated solution, and that means we are dealing with a low solubility salt. A low solubility compound. And if we are dealing with a low solubility compound, what kind of K should we use? Just type that in the comments if you think you know what kind of K we should use. Jason, yes, 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 yes. We are going to be using KSP. All right, awesome. So, do we remember when we're doing a KSP, where does the solid go? Does the solid go on the left or does the solid go on the right? Left, right, we don't know. Yeah. Yeah, it goes on the left. The reason being that if we have MgOH2, if we put our solid on the left and our dissociated ions on the right, when we actually do our KSP expression, we're going to get a nice tidy sort of a, oops, that's 2 plus, Mg2 plus, OH minus squared. Okay, don't write this next part down. If we were to have put the solid on the right, then our KSP would be 1 over concentration of magnesium times concentration of hydroxide. And that's just ugly, okay? So we always put when we're doing a KSP, the solid is always going to go on the left. That's as opposed to a precipitation reaction where the precipitate is the product and then we put the solid on the right. But for this one, we're going to do that. All right. So let's see. We have that and we want to know the concentration of hydroxide. Well, if our concentration of magnesium hydroxide is X molar, and I'm going to put that in brackets because, of course, there isn't really any solid, but that's okay. Then the concentration of magnesium is going to be X, and the concentration of hydroxide is going to be 2X. And if we can find the concentration of hydroxide, then we can find the concentration of H, and we can find the pH. So I'm going to say let X be the solubility of MgOH2. And that means that we have X for Mg and 2X for hydroxide. So our KSP then is going to be equal to X times 2X squared. And our KSP value, let me find my table here. That would be on page 5 of the data booklet. Magnesium hydroxide, 5.6 times 10 to the minus 12. Okay. And so now we have, I did something bad. Can anyone see what I did that was bad? It's on the right-hand side of that equation there. Anyone see? Yeah, where did I put it? I put it in the brachy. Yes, I did. It should have gone outside the brachy. Okay, let's get rid of that. There we go. All right, so there we go. Our squared should be out there because we're squaring the whole thing. Okay, which means we're going to have X times 2 squared is 4, and X squared is X squared. And then we have 4x cubed is equal to 5.6 times 10 to the negative 12. Okay, that means that our x cubed is going to be equal to 5.6 times 10 to the negative 12. Am I recording this thing, by the way? Yeah, I am. Okay, good. Whew. Okay. All right, and then x is going to be equal to, we'll take the cube root of the whole thing. Where did it go? Calculator. There we are. Uh-oh. Divided by 4. There we are. Okay, so 5.6 times 10 to the negative 12 divided by 4 equals 1.4 times 10 to the minus 12. And now we're going to take the cube root of that. And we get 1.12 times 10 to the negative 1, 2, 3, 4, negative 4. So that is our value for x. But we're looking for our pH. And anytime we're looking for our pH, we either need to know the concentration of hydrogen or we need to know the concentration of hydroxide. And then from hydroxide, we can go to hydrogen and we can go to pH, or we can go to POH and we can go to pH. So in this case, we are looking at our hydroxide, and our hydroxide concentration is 2x. So concentration of hydroxide is 2x. So that's going to be 2 times 1.2, 1.12 times 10 to the negative 4. And that is times 2 equals 2.24 times 10 to the negative 4. And our POH, let's go that way this time. POH is negative log of hydroxide. And so that's the negative log of 2.24 times 10 to the negative 4. Well, what happened there? Bigger, bigger, bigger. There we go. Okay, there's our POH is log, and we get 3.65, and then our pH is equal to the pKw minus POH, which is 14.00 minus 3.65, and we get 10.35. Whoops. Can we call it Bracky from now on? Okay, I'll do my best to remember. All right, we good? Anything else? Are we supposed to be handing the worksheets we are assigned? If you feel like it would be giving you more accountability, you certainly can. I'm not particularly wound up about it as long as you're keeping up on things. I think you guys are almost university people, so you can, be in charge of your own learning. At some point, I figure I should probably give you guys like a quiz to do. I don't know how it's going to work in terms of marks. It probably won't, but I can give you like participation marks for having done it, and I can give you feedback on how you've done on it and stuff like that.